top.
X plus 8x.
Very good. What about the denominator?
8 plus 7, 8 minus 1.
Excellent. I have to state two restrictions, one for each different factor, and only then I can simplify. Negative 7.
Oh, and 0.
8 minus 1. 1. Very good. So now I'm allowed to simplify. And the simplified form is a plus 8 over a plus 7. And this is the correct answer. Any questions? Now, if I ask you about this expression, when will this expression be undefined? So that's my new, I want to add this in. I'm asking you, when is this expression undefined? What will you say? A squared plus 7a minus 8 over a squared plus 6a minus 7 is undefined when what? Or, very good. Now I want to ask you to find the domain of a squared plus 7a minus 8 over a squared plus 6a minus 7. The domain is, you already told me when it's undefined, when it does not exist. Now I want to ask you, when does it exist? What would you say in mathematical terms? How do I write that? I have it in plain English. The domain is anything but negative 7 or 1. But how do I put it in writing, in mathematical terms? To negative 7, union, careful, negative 7 to 1, union, 1 to infinity. In plain English, anything but negative 7 and 1. Is that clear? Good. So remember these two concepts. That's one of the reasons why I insist on stating the restrictions. The restrictions not only give us when the function is undefined or the expression is undefined, but also the restrictions give, these two give us the domain of the function. So it has tremendous benefits to write the restrictions. And later on you'll see what happens with these restrictions in rational functions. Okay, when you get to pre-calc or calc. Okay, we are talking about multiplication. The same procedure of multiplying. So a over b times c over d is the same with ac over bd. We are going to apply the same procedure for rational expressions. This was multiplication of numbers, and it's the same property, the same procedure for multiplying rational expressions. So let's start with the first one. 12x cubed y to the 4th divided by 7 a squared b cubed times 14 a to the 3rd b to the 4th over 9x squared y squared. I always recommend simplify before you multiply. Can you multiply these two and multiply these two at the bottom? True, but it's better if you don't. Let's try to cross out and simplify as much as we can. So I see 7 and 14. 7 divided by 7 is 1. 14 divided by 7 is 2. I see an a squared and I see an a cubed. When I simplify by a squared, I only get an a left at the top. The same way I simplify b cubed with b to the 4th, and I'm left with a b at the top. Now I see 12 and I see 9. I will simplify both by, yes, 9 divided by 3 is 3, and 12 divided by 3 is 4. In the same way I simplify x squared, and 2 of those, and I still have an x. And y squared, and I still have a y squared left. I should have written all those restrictions first. These are single factors, a, b, x, and y. I have to do this before I simplify. So nothing can be 0 in the denominator. Therefore, the simplified form, I see a 4. So I see a 4, an x, a y squared, a 2, an a b, and a 3. So then 4 times 2 is 8. X, y squared, ab divided by 3. This is the correct answer. The simplified form of this product is 8xy squared ab over 3, assuming nothing in the denominator is 0. Yes? Yes? Go ahead. Becky? I'm sorry? So which one would you like to work on, and which one would you like me to work on? B, C, D. Please choose for me another one, and then you'll do the other two. Which other one you would like me to work on? You want me to work on C. Very good. So 16 plus 6x minus x squared over x squared minus 10x minus 24 multiplied by x squared minus 6x minus 27 over x squared minus 17x plus 72. Yes, just simply writing this took us a while, right? It's a lot of writing in this section, or entire chapter, I would say. First, I look at this problem, and I ask myself, are they all in descending order with a positive leading coefficient? No. Which one is not the way I would like it to be? The first one. So I have to rearrange, as we studied in chapter 6, and if you remember, I said your book does not say that, but then in chapter 6, they say, oops, we forgot. So that's why we had to do this from the beginning. For this, good. At this point, I rearranged the first polynomial, fine, but now it has a negative leading coefficient. What do I do now? Like we did in chapter 6, we have to pull it up. X squared minus 6x minus 16. Let's factor the denominator. How will you factor x squared minus 10x minus 24? That will not work.
X minus 2, x, no, sorry, x plus 2, x minus 12.
That I agree. The top. Excellent. The denominator. You understand how important chapter 6 is now, right? Both are minus. Good. What about the top? Do not try to do anything just yet. We still have to factor the top, and then we have to state restrictions. And please tell me, how many restrictions will you give? 4, right. 4. From here, you will say x not equal. From here, you will say x not equal. From here, you will say x not equal. And x not equal. Yes. So what is the factor form of the numerator?
X minus 8 is 2.
Very good. Now I'm allowed to simplify. Please tell me what to simplify. Very good, excellent. And write 1 and 1. Anything else? I don't have an x plus 3 in the denominator. X minus 9. 1 from the top, 1 from the bottom. Anything else? X minus 8. 1 from the top, 1 from the bottom. So then now what is left? There is a minus in front of the fraction line from here. So x plus 3 over x minus 12, assuming all these conditions are fulfilled. Otherwise, the expression is undefined. Say it again. Okay, are we working on B or D? Which one? Okay, it needs a lot. We need a lot of practice here. Okay, so we're working on B, so 2x squared minus 5x over 2xy plus y multiplied by 2xy squared plus y squared over 5x squared minus 2x cubed. Okay. Let's work on this for 1 minute. Remember, if something is twisted, as we discussed in chapter 6, it has to be rearranged. The negative leading coefficient has to come out, etc., etc. Let me know if you need help. Yes. No, you cannot simplify. You have to factor everything. You factor everything separately. What will you factor first? How will you factor 2x squared minus 5x? Greatest common factor. Remember, it's a binomial. Negative leading coefficient, no. Greatest common factor, yes. So we have to pull out an x. So I have x, and in parentheses, 2x minus 5. That's the factor form of the top. The same way you factor the bottom. And the other two. Yes. You have to pull out the y. Y is a common factor in 2x, y, and y. Yes. Yes. Very good. But the numerator here is y squared is the common factor. You have to pull out the greatest common factor. Always the greatest common factor. Do we need more time? Yes. Okay. You copied this incorrectly. It's negative in front of 2x cubed. And it has to be arranged in descending order no matter what. So let's work on this together. What did you factor out at the top? Good. What is left in parentheses?
2x minus 5.
Do you agree with the top? That x quantity 2x minus 5. Do we agree? Yes? Yes? Okay. Now the denominator. What would you factor out? Y. What is left in parentheses? Do we agree so far that the top is y quantity 2x minus 5 and the denominator the x 2x minus 5 and the denominator is y times 2x plus 1? Is that okay? Good. What about the numerator now? We factor out. Perfect. What is left in parentheses?
2x plus 1.
Excellent. The only one that creates problems is this denominator, correct? Because, first of all, it's not in descending order. Now it is. And now when I pull out, I have to pull out the negative leading coefficient and the greatest common factor. So when you look at this, what will you pull out?
Negative x squared.
Negative x squared. Very good. So I have x, 2x minus 5 over y, 2x plus 1 times y squared, 2x plus 1 over negative x squared. And what is left in parentheses?
2x.
You understand how important it is to factor out this negative leading coefficient, because then you will never be able to simplify these two. They will not have, they will not be the same, right? Okay, so now I have to state how many restrictions. The answer is 1 from here, 1 from here, 1 from here, and 1 from here. No restrictions for the numerator. So, please give me 4 restrictions. For this, what would you say?
0.
0. For this, you will say x not equal.
Negative half.
For this, you will say x not equal. And for this, you will say x not equal. Right. This comes from factoring, because these are just, I'm just really solving equations. That's what I'm doing there. Good. Now I'm free to simplify. What will I simplify?
2x minus 5.
2x minus 5.
2x plus
Perfect.
y.
Yes, a y. And the next. What is the simplified form?
Y over negative x.
Negative, because positive over negative is negative. Y divided by x with all these restrictions. Do we agree with this? Any questions? These problems require a lot of writing. Most of them are not very difficult, or a bit difficult, I would say. Difficult or easy is relative. But they require a lot of writing. Okay. Would you like to work on D before we do it together? Yes? Okay, here it is. 2x squared plus 5x plus 2 divided by 2x squared plus 7x plus 3 times x squared minus 7x minus 30 over x squared minus 6x minus 40. Okay, 2 minutes. Now these two are all of them are friendly. These two are easier. I claim that these are more difficult. Why? Why are these slightly more difficult to factor? Because the leading coefficient is not 1. So I have to use the long procedure. Yes. Now, the other way, you could take each and every polynomial aside and factor it and then put it back in. But the risk with that is that you may forget to put them back in. So I prefer keeping everything together. But if you know what you're doing, and if you feel better, if you take it aside and factor each and every one of them and then bring it back, that's fine too. I don't recommend that, but if it works for you, use it. It's okay. rewrite it again. Okay. Okay, yes, of course. Do you need it now? Okay. Do we need more time? Okay. Okay, let's start. So let's take the first one aside. I'm gonna just move to the next piece of paper, and we're gonna factor this. So we have 2x squared plus 5x plus 2. Descending order, no greatest common factor, no negative leading coefficient, no special product, and 1 is not the leading coefficient. So I'm looking for two numbers whose product is and whose sum is 5. Since the product is positive, both numbers have to have the same sign. Since the sum is positive, then I know which signs they have to have. Which sign they have to be both positive. So now what do I do? Four and 1. So then I go back and 2x squared plus 4x plus x plus 2. And I get 2x, x plus 2, x plus 2 from the other two. And now I look and I know it's positive 1. So do you agree with the factored form of x plus 2 to x plus 1 for the top of the first fraction? Yes? Can anyone give us the denominator? Or if you say no, show me, I'll do it. Do we need to show this the bottom, or you give me the factored form? So we said x plus 3 times 2x plus 1. Do you all agree with x plus 3 times 2x plus 1? Be easy to check. 2x squared. Positive x plus 6x is 7x. 3 times 1 is 3. Perfect. Now can anyone give us the top? Much easier because the leading coefficient is 1. I don't have to go through all these steps. What is it?
X plus 3.
Very good. Do you all agree with x plus 3 times x minus 10? And what about the denominator? How many restrictions on x will you write? Yes. X does not equal, x does not equal, x does not equal, x does not equal. Give them to me in any order you want. Doesn't matter.
3
Do you all agree with x not equal -3 from here, x not equal -1/2 from here, x not equal -4, and x not equal 10? Do we agree? Perfect. So now I'm free to simplify. I can simplify only top and bottom, not top with top, I've seen it done, or bottom with bottom. Okay? So only something from the top, a common factor top and bottom, or top and bottom. Okay. So I see common factors here. Which one will you get rid of? Okay, 2x plus 1. What else? X plus 3. What else? Very good. X minus 10. So then the simplified form, oops, I went too far. Simplified form is if x is not equal does not equal -3, -1/2, -4, and 10. Good. So what we know so far from this chapter: when a rational expression is undefined, how to state restrictions, how to simplify a rational expression, and how to multiply rational expressions. Correct? Okay, now let's look at division. Same thing. So let's see how we divide. Division of rational expressions. Okay. 4x squared y cubed over 15a squared b cubed divided by 6xy over 5a cubed b to the 5th. So where is the starting point here? The starting point is to state restrictions in the division form. Remember, when I divide two fractions, I can simplify each fraction by itself, but I cannot simplify across. I have to wait till I change it into a product. So if you remember the rule, a divided by b, everything divided by c over d, I keep the first fraction as is, and I multiply by the multiplicative inverse of the second one. This is the rule. It's the same rule we have to apply here. And then I write AD over BC. However, I have to state restrictions in the division form, and then when I flip the second fraction, I have to state restrictions again for that new denominator that I didn't have before. Okay, ready? So, for now, I'm going to write that a and b cannot be 0. I will write the first fraction, I will copy the first fraction as is, and multiply it by the multiplicative inverse of the second fraction. That's the rule of division of fractions. Now, I have a new denominator that I did not have in the first step. The new denominator that just popped up is 6xy. Therefore, I have two more restrictions to write. And they are x and y cannot equal 0. Now I'm free to simplify whatever I can. And here's what I will do. I see a 5 and I see a 15. 5 divided by 5 is 1. 15 divided by 5 is 3. I see a cubed and a squared. A cubed changes into just a because I removed 2 of those from each. B cubed and b to the 5th. B cubed goes away, but I still have a b squared at the top. Now 6 and 4 by 2. 6 divided by 2 is 3. 4 divided by 2 is 2. and I take away an x from both and a y from both. Kind of difficult to see, let's go slowly. 2 is left, an x is left, a y squared is left, an a is left, and a b squared is left at the top. And just the 3 times the 3 is left in the denominator. So 2 times 1 is 2, x, y squared, a, b squared divided by 9, and this is the correct final answer. Once I change it into a division, there is nothing new, because this is what we just looked at, multiplications of rational expressions. I would like you to work on B. 6x minus 12 over 8x plus 32 divided by 18x minus 36 over 10x plus 40. So take a moment and work on this. Remember, first of all, you have to completely factor everything. Then you will state restrictions on the division. Then you change it into a product. You state more restrictions, and then simplify the product. Sure. Do we need more time? Okay, tell me what to do first. Please walk me through as if you're teaching me. Good. What is left in parentheses? Perfect. The denominator? Good. Very good. Do we all agree with this factored form? Don't simplify, don't touch anything, just give me 2 restrictions. Oh, actually it's the same factor, so you will give me only 1 restriction. Perfect. Now I have to flip. Don't simplify, don't do anything. 6, x minus 2, 8, x plus 4, multiplied by 10 x plus 4 over 18 x minus 2. By simply flipping this fraction, I have obtained a new denominator. That new denominator needs a restriction now. As you see in the division, we state restrictions in two stages. In the division stage and in the product stage. So what is the new, bless you, what is the new restriction that I have to add to this list? Yes, x not equal to. Now, only now, I am free to simplify whatever possible. Is there anything that goes away? Anything?
X minus 2 and X plus 4.
X minus 2 and x minus 2, x plus 4 and x plus 4. It's 1, not 4. And I simplify 6 by 6 and I get 3. And then 8 and 10 by 2. And what is the simplified form? 5 over 12. And this is the correct answer. You will say that this expression, that is a division, simplifies to 5 over 12 only when these conditions are fulfilled. If they're not fulfilled, the final answer is not 5 over 12. Okay? Yes, Mike?
Can you flip the first 10 right there restrictions? Because I got the same thing. Or it doesn't, it depends.
If I can flip before I write the restrictions?
Yeah, because I got the same thing.
But you will not write the restriction for the numerator, will you?
No, I didn't.
So what restrictions did you write?
I still got x doesn't equal -4 and x doesn't equal 2.
As long as you have the correct restrictions, I'm fine.
Alright.
But it's safe to state restrictions in division form, and then when you change into a product, add. Any questions? Yes, Becky? Yes? Yes, oh, it's on the next page. Okay, so now let's work on C. 2 minutes. I know it's repetitive. If you say that we got the idea, we'll move on to something else. But if you still want to practice and work on these problems, I'll be more than happy to continue. I don't want to bore you with this unless we need the practice. We need the practice? Very good. Okay. Yes. This is showing how to practice. But it continues here. Can I add 15 minutes today and 15 on Thursday, and that will be the end of that class that we missed? Is that okay? Are you okay with that? Okay, thank you. And I have one more to give you back. When you finish C, you can move on to D, because D requires work. We need more time on this? Can we talk about it? I don't like this, right? I like this and this and this, but not this, correct? Why? Because it's not in descending order and it has a negative leading coefficient. So I will factor a negative 1 and write x squared minus 2x minus 8 over. What is the factored form of x squared plus 7x plus 10? Very good. Excellent. What is the factored form of x squared minus 11x plus 28? Very good. And the factored form of x squared minus x minus 42? Very good. At this stage, I have to write 1, 2, 3, 4 restrictions. What are they? X not equal. Perfect. Don't simplify anything yet. We have to factor the top. I put minus in front, and I have to factor the numerator. And flip the denominator. I'm sorry, flip the second fraction. Okay, so x squared minus 2x minus 8. How do I factor x squared minus 2x minus 8? Very good. And now, when I flip the second fraction, I obtained a new factor in the denominator that I did not have before. X minus 7 I did have before, but x minus 4 I did not. So I have to add to the list of restrictions one more number, which is 4. Now I'm finally free to do whatever I want. Not really, but simplify. So what goes away? X minus 4 goes away indeed. X plus 2 goes away. X minus 7 goes away. And then the simplified form has a negative in front. What is left from the top?
6.
Yes. And x plus 5. Remember, the negative goes in front. So this is the correct answer, including this. Okay. One last one here. Ready? 2x squared minus 3x minus 20 over 2x squared minus 7x minus 30 divided by 2x squared minus 5x minus 12 over 4x squared plus 12x plus 9. A lot of work on this one. Let me know if you need help, please. The denominator is going to be 0, so x plus 1 is not 0, it means x not equal to 4. X plus 1 not equal to 0 means x not equal to 4. Yeah, because you have to write x plus 4. X plus 4 not equal to 0, you move 4 to the other side. Is that okay? Okay, so let's take each and every one of them aside, or if you have the factored form, I'll put it in. Or if you want me to show any of these. Do we have the factored form for the top? Yes? 2x minus 5, x plus 4. Do we all agree with this? Excellent. The denominator then. 2x minus 5 and x plus 6. Do we all agree with this? Yes? We can check. 2x squared, positive 12 and minus 5x is not negative 7x. Careful. So let's check the first one, 2x squared, 8 minus, okay, so positive 8 and minus 5 is not negative 3x. Very good. Okay, very good. Careful. Good. I asked if you agreed, so I didn't check. No. Okay. No, don't assume. It's possible. We all make mistakes. Okay. Do we have the factor form for the top? Okay. 2x squared, negative 8, plus 3. That's correct. And the last one? Very good. That's a special product. At this stage, I need 1, 2, 3 restrictions. From here, from here, and from here. Do we agree with this so far? What will I have to do next? What will be my next step? I am allowed to simplify each fraction by itself, not across, but I'd rather simplify at the end. So 2x plus 5, if you're comfortable with doing that and you know what you're doing, please simplify before rewriting this. But you cannot simplify across in a division. So that's my fear. Okay? So 2x plus 3, everything squared, over 2x plus 3 and times x minus 4. I did not have this before, so I have to add one more restriction, which is x not equal 4. Now I'm finally free to simplify. What goes away? Yes, they go away. They go away. Yes. So the simplified form, assuming these conditions are fulfilled, is good. Now, I think we had enough of multiplication and division. Do you think we understand how to factor simplify state restrictions? I should say factor state restrictions simplify. Yes? Yes? Okay. So now we are ready to look at adding and subtracting rational expressions. So the first step is when the denominators are the same. And that is not a difficult situation. So let's look at 6x minus 5 over x minus 10 minus 3x minus 4 over x minus 10. Yes? Yes? Yes. So we're looking at 1, 2, we're looking at chapter 7, which is 1, 2, 3. So these first two. Thank you. Okay, so I'm looking at these two rational. I look at these two rational expressions. I'm not asked to multiply or divide them. I'm asked to subtract them. The only restriction I have to write is that x does not equal 10. I will copy the denominator and then carefully rewrite the numerator as 6x minus 5. But then I have negative 1 that needs to be distributed to both terms at the top. So this negative in front of a fraction line behaves like negative in front of 3x minus 4 in the same way. Not to the denominator. And I cannot take the negative to the top and to the bottom. That would be a mistake. I can only take it to the top or the bottom. We almost always take it to the top. Okay? So then minus 3x and plus 4. Then the simplified form of the top will be 3x and then minus 1 divided by x minus 10, and no one can further simplify this. And this is the end. That's all I need to do. Just write the least common denominator and perform the operations at the top. Of course, I have to state restrictions. If at the end I can simplify, I will, but there is nothing I can simplify now. And here's another example. 2x squared plus 6x over x squared minus 2x minus 63 minus x squared minus 3x plus 21 over x squared minus 2x minus 63 and minus x minus 7 over x squared minus 2x minus 63. Okay, it took me a minute to write it. It's long. But let's take a look at this. I'm asked to add, subtract.
Just so it's the same as our example.
Um,
2x squared plus 3x.
Oh, how did I come up with that? Thank you, thank you. Instead of, I don't know. Thank you, thank you. Very good. So I look at this, and I realize that these three fractions have the same denominator. Therefore, I'm going to write the same denominator, but already factored. Can anyone give us the factored form of x squared minus 2x minus 63? Notice that when we add and subtract fractions, I never factor the top. We don't care. We only need to factor the bottom, not the numerator. The numerator may be factorable at the very end. If it is, I'll try it, but not when I add and subtract, till the very end. Okay, so what is the factored form of the denominator?
X minus 9, X plus 7.
X minus 9 and X plus 7. I already have two restrictions to write, one for each factor in the denominator, and those are 9 and negative 7. True. Now please dictate slowly the numerator. Two x squared plus 3x. Now careful.
Minus x squared
Yes?
plus 3x.
Yes?
Minus 21
Excellent.
minus x plus 7.
That's it. Do we all see this and we agree with it? What do you think is the next step? Exactly. I have to combine like terms in the numerator. I cannot simplify anything. I cannot do anything till I fully simplify the top or combine like terms. 2x squared minus x squared. Remember the degree? That's where I start. 2x squared minus x squared. Very good. I have 3x plus 3x minus x plus 5x. And then I have negative 21 plus 7. Very good. Negative 14. Now, since I obtained one fraction, I have to try to factor the top. If it's factorable. Is it? Yes. How do I factor it? X plus 7 and x minus 2. I stated my restrictions. I am free to simplify. Now, if there is something that goes away, is there anything that goes away? That's it. So the simplified form of this addition of rational expressions is this, assuming the conditions are fulfilled.